welcome everybody. Thank you for joining our next or another Show the Code event. This time we have partnered up with Connect Ventures, and thank you to Connect Ventures for obviously helping us pull this event together. We've been running these events for quite a while in partnership with lots of VCs. Really, the aim of the game is to give you the opportunity to hear from and speak directly with engineers from VC-backed, fast-growing tech startups to really understand and find out what they're building, what's cool about the technology they're building, to find out a bit more about their technical challenges and what it's like to be an engineer at one of these companies. As I say, we've been running this event for a while now, and we've actually been doing it in partnership with an awesome community called Silicon Roundabout. Silicon Roundabout are a pan-European tech community really aimed at supporting engineers, people in product and data, to support them with startups, VCs and networking, and really hoping to sort of, I guess, support their careers. To kick things off, today's event is going to be, the agenda looks like me introducing Francesco from Silicon Roundabout. He's the co-founder and director there. We'll then have presentations from 3 Connect Ventures-backed startups. So that's Citymapper, EduMe, and Timeular, of course. We're going to be speaking to engineers at each of these companies, and it's your opportunity to ask them questions, find out more about what they're building. One thing I really want to encourage is for you to actually start conversations with each of the speakers today. So you can use either the Q&A function on Hopin to ask questions, but also start one-to-one direct conversations with each of the speakers. So you can do that and find out more. To kick things off, if Francesco's ready, I'd like to introduce Francesco. He's the co-founder and director at Silicon Roundabout. Francesco is going to tell you a little bit more about those guys and what they're doing. Welcome, Francesco.
Great, Sam. Thanks for the intro. A pleasure as always to be here. And I'm sorry if there are regulars here. You're going to hear the same spiel over and over, and that's probably going to happen every time you join. Francesco here, like Sam said, co-founder and director of Silicon Roundabout. Silicon Roundabout as an organization has 3 main goals. One is keeping the community active and running, the largest tech meetup in Europe, and hopefully back meeting up in person. As of now, keeping the events going. On the technical side, since I'm an engineer myself, software engineer myself, want to keep also us interested and engaged, and therefore we welcome the opportunity to continue to partner up with Tech3 and making sure that we can actually get to talk tech from a startup perspective and hear other tech leads, CTOs, software engineers actually discuss what technologies they're building, what tech challenges are solving, and so that we can all keep learning from one another and keep the conversation going on the tech side. We also run a micro VC for pre-seed and seed stage high technology startups, which I spearhead. And of course, we're always welcoming founders to continue to join the network because we've made recently 3 investments and we want to continue to make more and to keep powering startups, not just hosting them on stage like we used to be doing for nearly 10 years now, but also empowering them. And then lastly, currently run also an academy, a digital platform to upskill digital talent across different aspects of the tech sector and helping startups crucially accessing funding for these new people. So pretty busy organization, as you can see, but right now, really the focus is tech because, like I said, ultimately, one thing that always has been maybe lacking from the general pitching events that you can find everywhere is that there isn't maybe a lot of space for us CTOs, tech leads to talk tech and share what we've been building and getting feedback, and vice versa, going back to the sitting stage and learn. So that's all from me. That's all about Silicon Roundabout. If you want to connect, I'm going to drop in the event chat my LinkedIn details. Feel free to reach out and connect. If you're on GitHub, you can also find me here. The Silicon Roundabout thing has got a company page, and that's pretty much all. If you do reach out on LinkedIn, please tell me you come from this event. I get spammed quite a lot, so otherwise I wanted to accept, but otherwise I pretty much accept everyone that want to connect. that's all from me. Happy to just sit back and leave the stage for startups, so that actually we can learn some more new thing about tech and what these guys have been building.
Yeah, awesome. Thank you so much, Francesco. Thanks for the introduction, obviously, about Silicon Roundabout. So without further ado, I'd like to introduce James Backhouse, who is a full stack engineer at EduMe. Welcome, James. We can see you.
Hello.
So James, really, it's over to you. We'd love to hear, obviously, a bit more about what you are building at EduMe. And yeah, I think that's it. Over to you.
Great stuff. Hello, everybody. I'm going to attempt to share a presentation with you, and fingers crossed it's all going to go well. So here we go. So hopefully you can all see that. So yeah, I wanted to talk a little bit about a few things. It'll take about 15 minutes, and fingers crossed we will keep to time. So yeah, talk a bit about what EduMe is, what we do. Then the main theme today is around how we simplify access to our product for our users, and yeah, just get into a bit of detail around some of the work we're doing on localization. And obviously, if you've got any questions, feel free to shout. So I guess let me start with my least favorite topic, which is myself. I've actually been at EduMe for just about 6 or 7 months, and I've only really been a developer for about a year and a bit. So I've spent, but I'm not also 21. So I have spent most of my career doing stuff that is entirely unrelated to software development. And I share that because I guess, if any of you are looking for a job, then know that at least at EduMe, we are prepared to take on people who haven't got a classical developer career. I won't go into detail, but I started as a management consultant. I hated it. I went into restaurants, worked at Leon, did some operations stuff there. Then I did marketing at Evan Sarkos Carluccio's. I tried to start a business, and then the global pandemic hit, and that was a bit of a disaster. But in the process of doing that, I discovered that I love software development, and was lucky enough to persuade the guys at EduMe to give me a job. And here I am now. And another guy started with me, has been a chef for 10 years before he became a developer. And there's some people who've done nothing but development and have, maths degrees from Cambridge, first in computer science. So we're not all new to the software development game. So that's enough about me. Let's talk about EduMe and and what we're about. So we're working on the basis that although most of us are now sat around a desk, I imagine, or looking at a screen, 80% of the global workforce is deskless, and we're being taken over by quotes millennials. So people born since 1981, and no surprise, we're all using smartphones, and it's changing the way that we consume information and we communicate. So we are a workforce success platform, which means that we think about how to engage staff, how to engage them, and how to communicate with them. And we are working with companies like Uber, Deloitte, Vodafone to help them with their many millions of employees. So what is it about our platform, I guess, that makes it a bit different? So first thing is it's a mobile first platform, and we try to be as intuitive as possible. Some of the feedback we get from our customers is that it's a very, very easy to use platform. So when they're trying to deliver training or information to their staff, then and their staff are not they're deskless workforce, so they're not used to spending their entire day staring at a screen. They find it very easy to use. We focus on things being concise and engaging, not long 40-minute slideshow presentations, or indeed 15-minute slideshow presentations like the one I'm giving now. And it should be accessible, right? And it should be something that the user enjoys doing, and that they want to come back to, and they come back to it frequently and don't spend very long at any given time. So in terms of how our customers actually use us, the main thing, I guess, the where we started out was around onboarding new joiners. So you can imagine someone like Uber or Deliveroo, they have an unbelievable number of drivers or riders, and there's new people joining all the time, all over the world, and that is quite a logistical challenge because they need to train them in all sorts of things, fundamentals around what does being a driver for Uber look like? What are some of the compliance things that you need to be trained on in order to start the job, etc. So there's an awful lot around that. There's obviously continuous learning, for employees. There's always new things to be learned, updating them. And also there's just more generally a sense of belonging to a company that cares about your well-being as an employee, and making you feel valued, and our platform can help with all of those things. We're growing quite fast. So I joined probably towards the start of the recent burst of growth. So we have had a good pandemic, which we feel very grateful for. We know that it's not true of many people, but we raised $5 million of funding from a Silicon Valley VC last year. During the pandemic. When I joined, there were about 20 odd people in the company. I think we're now about 40 odd, and we expect to be quite a lot bigger than that by the end of the year. And these are some of the clients we work with. Some of them you will recognize, some of them you may not, but they're truly global. Tego, for instance, one of our first customers, is based in mobile network based in South America, actually. So and there's some big guys like Uber and Deliveroo, etc., who keep us busy. So I won't talk through this slide in detail, but the reason we have grown is because people like our product, and our product makes a difference to our customers. So let's just take the Uber example. So they are using EduMe to train their drivers. There are millions of Uber drivers around the world. We're used by Uber worldwide. So we've managed to increase the supply hours provided by the drivers by 8%, average driver rating as well by their riders, and reducing onboarding times. And those numbers, look maybe smallish, single digit, but if you can imagine on the scale of Uber, that makes quite a material difference to their performance. And we're really happy that 98% of Uber's drivers say they'd recommend EduMe to their colleagues. So that feels like that's important to us, that the drivers enjoy it as well as the admins and the people that are actually buying the product. So in terms of making life as easy as possible for our users, and I'll start talking a little bit more about the product and some of the things that we focus on as a company. So it is, like I say, we've got millions of users, and it is super important and fundamental to our success that they find using our product as easy as possible. So just to start at the top, fundamentally we are a mobile-first platform. You can either use the web app or you can browse it on mobile. You can use the platform on the desktop. The vast majority of our users will access it via a mobile browser or the app itself. We have, for some of our customers, actually become embedded within their own in-house apps. So at the moment they use a web view. So although it's within the app, they're actually accessing our web platform. I don't know if anyone's come across Fountain, but they're the world leaders on basically hiring and onboarding new users, new staff members. So for companies which have typically used by companies that have an awful lot of staff, like Uber or Deliveroo, then they allow you to hire and onboard people at scale, and we're fully integrated with them so that the EduMe courses can be created as part of an overall workflow that the company requires their new joiners to go through. We're also integrated with a company called Braze that allows admins to generate passwordless links for their users. I'll talk a bit more about that in a second. So we provide, as a company, I guess 4 main ways in which users can log into the platform. So there's a straightforward, what you might imagine: use your email, or indeed you can use your phone number. Here's your email, enter your password, off you go. That's what everyone has. We also allow admins to generate what are so-called self-sign-up links, where they can send a link to a user. When the user clicks on it, they are automatically enrolled in the course. So if the admin provides a link to a course, then the user clicks on that link. they're automatically enrolled in that course, and all they need to do is enter some basic details, their name, typically an email or phone number. They enter a password and they're in. So we don't require, small things. We don't require you to double enter your password. We don't require you to then go and check your email and get the code from the email and enter it back in order to get in. This is for people who are on the move and want to get into the training quickly. We also allow companies to set up, use their existing authentication, so using an SSO process. So again, this is set up for either SAML or OAuth setups, so that if you have, let's say, a company login that's already set up, you can use that to then also authenticate yourself into EduMe. And then there's something called, we call them seamless links, so passwordless login. And this is a link which actually has zero authentication on it whatsoever. So allows a user just to click on the link and takes them straight into a course and creates a user account for them within EduMe immediately. So there's a sort of security risk in the sense that if you don't want anyone else to see the content behind that link, then you need to be careful with it. But it's used, for instance, when we are embedded within an app. Behind the scenes, there's a passwordless link that will allow the user within the app to move from the native app content into EduMe and back again without the user noticing any authentication happening. So I guess a nice way to streamline the user experience, but make sure that we're tracking the user in the back end on our side. So that's a bunch of stuff we've done already, and I guess is one of the, where we've had some good feedback on it, but there's always more you can do. So here's a nice big map of the world, and I'll come back to Uber because they're a big name and everyone knows who they are. They work in 85 countries worldwide, but they use basically the same onboarding program for the new drivers everywhere. But obviously, 85 countries don't all speak the same language. So we already offer 35 languages in our platform. But, and this is where I'm going to get a bit into the detail, and forgive me, so the detail here is what's important. So we allow admins to set up groups of users, and within that group you can create a number of different courses, etc. But the language is set at a group level, not at a user level. So if let's take a Belgian user who might speak Flemish or French. So if they want to present a course in the onboarding course in Flemish, they need to have a Flemish group. And if they want to have the same course but in French, they need to create a completely different group. Now that's sort of fine, but it's not really what having exactly the same courses just in a different language in a different group is not a very helpful way of setting things up, and means that then all your group reporting is not very helpful. For Uber, that's not a meaningful distinction. They treat them as basically the same users, but they're just consuming the same content in a different language. So it kind of breaks a little bit when you get to that. So we want to set things up at a user level. So now, forgive me, this is a really ugly slide, but what we have here is our database setup, and I just wanted to get into detail to explain where we are. So just to talk you through, these are the tables in blue in the middle here. So a user exists in a user table. There's a joining table called users groups that takes them to the groups table. So there's your Belgian group, your Flemish group, or your French speaking group. That's then linked via a joining table to a courses group, and then within courses you have lessons. So that's how you get from a user to an individual lesson, okay? Now, language is set at a group level. So as I say, if you want to create a new lesson in a new language, you need to create an entirely new group, which will then link through to a new lesson. And again, to get into detail, the lesson content we store as a JSON blob. So it's literally the word for word, the content, the images, the video, etc. is stored there. What we're working on at the moment is changing things so that actually we're going to create a new table. So here, the lessons, rather than within the lessons table containing the content as a JSON blob, is actually going to reference keys. content keys, and those are going to be linked to a new table called localized content. So here there'll be a content key, and then it will contain a localized value, basically a language specific value for each of those keys. And those keys could be text, they could be an image source, they could be a video source. And that would allow us to, for a single lesson, to hold within the localized content table multiple different languages, so that you no longer need to have a different group in order to serve a lesson in a different language. But that's the database structure behind the scenes. How do the admins actually interact with that? So I guess this is where I want to talk a bit about I'll tell you what we're going to do, and I'll explain how it is an example of how we approach development in general. So the first version is pretty rough and ready, and I hope that the guys who did the work don't mind me saying that. But the localized content we're actually going to export into a Google Sheet, and I put a screenshot on the right, so it looks as sort of ugly as a regular spreadsheet does. But fundamentally, down the left you've got the content keys, and then you basically have a column for every language that you want to present it in. And we export the default language, so let's say that's English. They can just add a new column, and then they go about the translation process of translating the copy, sourcing a new image if you need to change that, sourcing a new video, etc. So they would literally manually enter the content into that Google Sheet, row by row for each of the content keys. They then send it back to us, and we do, again, this is a sort of version 1 or version 0.1. We would then verify that, because if you can imagine in a Google Sheet, there's very limited validation. You could do all sorts of things might break, and if we allowed them to upload it directly into our admin console, then there's a decent chance that something might go wrong. So we do some validation, we then upload it, and then in the admin portal, the admin user will then have the ability to basically to generate different course links with just simply using a URL parameter. So that there'll be a query at the end around language equals EN, ES, FL, whatever it might be. So the end result for the admin user is something very simple. We're just changing a URL parameter. Now that is version 1. It's reasonably crude, but I guess this is where it comes into how we approach these things. If you think about the kind of customers that are going to be using this, they tend to be large and quite sophisticated, and to have quite sophisticated admins and in-house dev teams. So they're more than capable of handling this, and and this is, I guess, a relatively simple thing for us to get out the door. It's not that simple, but it's the quickest way. What would we do after that? Well, maybe the next step is probably going to be automating this so that when they've updated the spreadsheet, it doesn't have to come back via us for validation. They can just self-serve themselves completely. Version 3, you could easily imagine, obviously, ideally, you'd end up with this probably in our admin panel in the UI so that they can do the translation there. But you could say, well, isn't this a bit crude? Don't you want to have something more polished, ready to go? But actually, if we did that, it would take a lot longer. Have a lot more work our side, and there's a fairly high chance that we would go down the wrong track. And we've got quite a lot of customers, but we're still a B2B business, so we work closely with our clients to understand what it is they want, and we try to build and then iterate. So this is the first iteration, and they may say, actually, it's absolutely brilliant, you nailed it. It's quite unlikely that's going to happen. They're probably going to say, this is great, can we change the following things? And we would rather go through short, faster iteration cycles in order to deliver something that is really going to be used and deliver value, rather than try to create something really polished that then takes a lot more work, takes longer to develop in the first place, and takes a lot more work to change, I guess, when we get any feedback after that. So that was that. This is a slide saying, reminding you about what we do. So that's I guess a quick introduction into something that we're always focused on, which is making life as easy as possible for our users. And that was just a kind of a bit of a deep dive into that particular project. As Sam said at the start, we're hiring. We've got junior, mid, and senior positions open. You should be able to see the link below in the notes. We visit our website as a careers section. We would love to hear from you. Our tech stack is based on React on the front end. We're apps in React Native. We're using Node on the back end and a Postgres database. So hopefully reasonably mainstream technology, and we would love to hear from you if you're interested in working from us. And if you have any questions, do shout. Thank you very much.
Hi, James. Thank you very much for that presentation. That was great. And it's great to see, just how seamless you really are making things. I can imagine lots of people across the team, across many organizations can learn from that, from a product perspective, I guess. We do have one question in the audience here. It's from Lukash, who's saying, for the SSO and SAML, do you allow customers to configure that themselves, or are you always doing it for them?
Good question. So at the moment we do it for them. I guess an example of what's the quickest way to build it is to build it so that we do it rather than making it self-serve. Yeah, so good question. At the moment we don't have, the configuration is fairly there's quite a lot of bespoke elements typically, so it hasn't made sense so far for us to build a self-serve version of that.
All right. Well, James, thank you so much again. Thanks for presenting. If anybody has more questions for James, you can actually message him. You can tag him directly in the chat function here. Yep. Again, check out the careers on either TechTree or on the EduMe page. Thanks, James. You can now leave the stage.
Thanks.
So next up, we have joining us Sam, Giles, and Ben Jones from Citymapper. Both are engineers, are going to be talking about how they're scaling, as well as telling us a little bit more about their transport pass, their sort of all-in-one transport pass. I'm pretty sure everybody here will be familiar with Citymapper now, so looking forward to seeing more behind the works. Hi, guys. Welcome to Show the Code.
Hi. Thanks very much.
Hey, yeah. Awesome. So I'll leave it to you guys to go ahead and present. You should be able to share one of the screens now.
I'll just try and figure out which screen to share. Hello, everyone. I'm Sam. I'm a software engineer at Citymapper. Ben, would you like to introduce yourself?
Yeah, I'm Ben Jones. I'm also a developer at Citymapper, and I work mostly in our pass team, which we'll be talking about a bit after Sam's given us some overview of how we're doing stuff with our cities.
Yeah, cool. So let me just explain a little bit about what Citymapper is and what makes us unique. So Citymapper is designed to be like the ultimate transport app for mobility in cities. Ben, if you could do the next slide, please. So one of the cool things about cities is every single city I've ever been to, and I'm sure you as well, every city is unique. In the app, we've kind of built around this concept of uniqueness. You'll find a city switcher, and depending on where you are in the world, we'll suggest, you might want to switch your app to be in this city, where we'll provide a unique experience for that city. Next slide, please. So, for example, if you're in Spain, in Malaga, you'll get certain transit options. And then in the next slide, please. If you're in London, you'll get others. So every city is unique. You've got, some cities have ferries, some have funiculars, some have taxis, some have cycles to hire, some have underground metros, trams. There's so many different combinations. And that's what we specialize in, giving you a unique view of the city that you're in. If you could go to the next slide. Now, this is quite a complicated problem. We take like thousands of data streams or data feeds, and we kind of do our magic for each city with we have city specialists, people who specialize in a particular city or a particular region. We have data scientists. We have pipelines of data to kind of build this sometimes messy data into something that we can use to provide a great experience for that city. So the key thing is that we provide unique experiences per city. If you can go to the next slide, please. So right now, as I showed the city switcher earlier on, we have around 90 regions or cities that we support. And this number is growing. So if you go to the next page. So the way that we deploy these cities is each city or region is deployed in isolation. So that consists of a set of services that do routing for transit, walking, cycle, like maybe you're going to do kick scooters or walk. We have lots of different services that do all these kinds of things specific to that region. But the thing that makes that unique to a city is the data that came out of that data pipeline that's for that particular city. So if you do the next slide. So we have a bunch of HTTP-based API services, and then next slide, please. We have a bunch of region-specific data that's used by those services. So this is what makes up a deployment of a region. If you could go to the next slide. So we kind of have two different things here as well. We have the code that's written by software developers, and we have data that's maintained by region and data specialists. And on the next slide, I point out that both of these different teams have different release cycles and different objectives. So on the next slide, it's important to the city specialists that data is correct, it's up to date, there's the uniqueness about the city, and it's comprehensive for that city. And then on the next slide, it's important to software developers that it's reliable, bug-free, scalable, has new features, and can work for the users of that city so that they can actually use the data. So there's kind of two competing things here. On the next slide. So everybody wants to make changes whenever they need to. But as I pointed out, right now we support approximately 90 regions. And everyone wants to make changes in every single region that we support. And on the next slide, we're also trying to grow the number of regions and cities that we support across the globe. So as you can imagine, there's lots of change that needs to happen, lots of deployments of data and code, and all at different times. So we've kind of turned to Kubernetes, on the next slide, please, as a potential solution for this. So if you're not familiar with Kubernetes, Kubernetes has an API that allows you to kind of create the kinds of infrastructure components that you might want to deploy applications. So for example, on the next slide, I have an example of a resource in Kubernetes that you can create via its API of a deployment. So this particular deployment here is just a standard Nginx deployment. Maybe there's some static site there, but we can create this deployment. Kubernetes will do the work to create 3 replicas, spin up the containers, open a port that we can direct a service at. And it also gives us service discovery, and there's another API resource for that. So we have a mechanism for deployment of deployment of code out of the box, but we don't have anything for the data that we need. So on the next slide, I have put together an example of an API that we've created using the custom resource API in Kubernetes that allows us to extend Kubernetes to the concept of a region, which is kind of the abstract term for the data that we need to deploy for a specific region. So here you see an example of London. It has some data versions, which are the build IDs that the data specialists come up with after kind of taking all this raw data and coming up with some cleaned data that we can use in our applications. So this makes up a region. There's perhaps a routing graph, perhaps there's station IDs or stop IDs, a timetable, and obviously there's some magic as well. So we have this custom resource. Now, how does Kubernetes take that to create the actual kind of services hydrated with this data? I'm just going to take a little diversion into how Kubernetes works, more or less. in terms of control loops. So Ben, please, next slide. So Kubernetes has this concept of, it has a state of the system, and the resources you create in the API are the desired state of the system. So we kind of have a control loop that tries to move the desired state of, the actual state of the system towards the desired state of the system. So how that works is we observe the actual state, and then on the next, we find the differences from the desired state, and then we kind of create a command list on the next slide. We issue a set of commands to move the actual state forward based on this difference. And then on the final animation, we repeat that until the state matches the desired state. So we kind of have this observe, find the differences, issue a set of commands, and repeat this until the state of the system matches what we want it to match. Cool. So at the core of the thing that we've built, the operator it's called for Kubernetes, is a really simple control loop. On the next slide, I've got some pseudocode. And we're using a Python framework called Kopf, which kind of does a load of the watching of resources in Kubernetes and observing of the actual state. But basically, all we do is we kind of create a hash of this set of data to kind of get an ID for that build. We compare that to the deployed data, and if it needs an update, we'll roll out a new version of the stack automatically. And that kicks off another control loop that handles rolling out a stack. It's kind of built on control loops and on control loops. So the final thing I wanted to say about this particular thing was on the next slide is that this is enabling the region and city specialists to launch new cities, test new data, and iterate faster. So instead of having to do kind of long processes, we can kind of create a resource in the API, and something will go and create that for us with all the monitoring, the alarming, all that kind of thing. And then the final thing I wanted to say before I hand over to Ben to talk about Pass is we're not quite there with this solution yet. We're still building this, improving this in production. And there's still a ton of interesting problems to solve, such as how would it look if we wanted to deploy, say, New York in a New York data center automatically? How would it look if we wanted to manage really large clusters on Kubernetes and be cost effective and make management easier? There's a whole bunch of problems we've not yet solved. And that's something that hopefully you could come and help us with. So Ben, I'll hand over to you.
Thank you very much. Thanks, Sam. So I'd like to give a quick chat about sort of like, I guess, a bit of the structure that we've gone for the infrastructure of our Citymapper Pass systems, and tell you a bit about what Citymapper Pass is as well, and why we chose that infrastructure based on the problems that we were facing. So Citymapper Pass, first of all, is a subscription service which allows you to have access to transport in London in particular. And as you might have seen from some of Sam's slides, transport is a fairly complicated thing to begin with. And so our pass is something which is trying to simplify that by combining access to public transport, things like tube, bus, train, and then combine that with more newer and more private modes. So that would include things like black cabs and taxis, as well as some of the modes that we're seeing crop up at the moment, like bikes and scooters. And one of the other advantages of the product is that it integrates directly with our app to allow you to, say, book some of those private services. And it also works via a sort of physical or virtual card. So you can have a plastic card in your wallet, or you can have a virtual card in your Google Wallet instead. And so we built the structures of Pass, which on top of what we kind of try and think of as a base, which contains all of the code that we need to sort of, which different parts we handling as a large mono repo and Django and collected Django apps. So we've got our base, which, as I mentioned, sort of provides access to the database and providing library code to other parts. And then we have our email cannon, which we're using to communicate with our our users, a real-time feed from our pass provider, and the structure in which we use so do things like know your customer checks, which are all built on top of AWS Lambda. And we'll have a look at why some of that we've chosen Lambda for some of those systems in a bit. And then we have other systems like our client APIs, which include how our app is able to talk to our systems, as well as the customer relationship management system that we built is able to talk to sort of the larger pass structure, which are built on top of EC2. And then we also have an authorization handler to sort of authorize transactions as they're coming through. And we, again, chose to build that on EC2 as well. And we look at sort of what the problems around that auth handler are and why we chose EC2 in a second. And again, we'll have a look at some of the problems around that real-time transaction feed and why we chose to build that on top of Lambda instead. So looking at how we build Lambdas and why we've chosen this. So our real-time feed is from our card provider, and they will send us the transactions as they come through to us, which you might think means that we're getting sort of transactions all the time, but that isn't necessarily the case. So, for example, the principal public transport provider in London is TfL, and their behavior is incredibly bursty. So they will store up all of the transactions that they have for a particular user, and then send them usually in the tiny hours of the morning. But they're going to then be doing this for all of the users that we have on pass. So we're getting many thousands of transactions through in very, very short period of time. And how do we sort of want to cope with that bursty behavior in a way which allows us to work out how to sort of pass on the cost or absorb the cost of those transactions. And so we manage that by using AWS Lambda. And so our Lambdas work in pretty much the same way. We're changing based on where that event source is coming from. So sometimes we have Lambdas which will put messages onto SQS queues, or in the case of when processing transactions from our payment provider, there's an API gateway which will place messages on top of an SQS queue. And then we'll have a Lambda which consumes that SQS queue, and the Lambda will have access to the database to be able to make relevant checks against a user, make sure whether we want to absorb the cost as part of that user subscription, or if we want to be able to charge the user because it's something which is outside of the subscription. And then we also have, in addition to that, either an SQS queue, which the Lambda will put the message on if it's unable to handle the message. And so that means we don't drop any messages on the floor, or we can, if it needs further processing, put it onto the SQS queue of another Lambda. And so the reason we've chosen to use Lambdas in this structure is that the processing of these transactions as they come through can happen really super asynchronously. We don't have to worry about passing on the cost to a user straight away. It's something that we can take some time to think about and work out what we want to do, and then pass that cost on to the user, or as I said, absorb it as necessary. And so Lambdas are a great way of doing this because we can have messages sitting in SQS queues for up to 2 weeks. And so we can slowly process them as we need to, based on the volume that's coming through. And the SQS queues can, I don't think we've ever had to worry about sort of the limit of the amount of data that we can have in there, also in the form of messages. So we can have those many thousands of transaction messages queued up, waiting to be processed by our Lambdas. What the Lambdas do provide problems with is how we manage database access. So we manage database access and concurrency with on our EC2 machines in a particular way, and I'll have a look at that in a bit. But with the Lambdas, we can't be sure if we're coming into this with a cold Lambda container or one that's already spun up and running. And so we've had to write some sort of custom logic that we decorate all of our Lambdas with, which will give us things like logging and error, sort of like both for normal system logging, but also for sort of our error alarming But on top of that, it will also sort of try and check what our server resources look like. And so it will try and update those on a minute-by-minute basis, because it would usually pick those up as we have a cold start from a Lambda. And also to make sure that the database connection is fresh, because I think another one of the issues we came across with using Lambdas connecting to the DB is that the Lambda might be hot, but the connection to the DB might be stale. And so we've got a look, as I said, some custom decorators that we set up in our Lambda to do that. And the other way that we manage concurrency with our database is directly with AWS's controls. So we're able to control how many Lambdas are accessing the database at the same time by managing how many Lambdas we can have running at the same time. And that's how we control concurrency and make sure we don't overload our database with concurrent connections at once. And this is in contrast to how we manage our EC2 instances, which I think have a relatively straightforward structure, where we have an application load balancer in front of an EC2 instance. And we're managing how many of those instances that we'll have based on them being part of auto scaling groups. And then on the actual instances themselves, we'll have ingress control by Nginx, which will then talk to a pretty standard Django app, which would be built as we saw. We've got sort of with those client APIs, or with our authorization handler, which will then talk to PG Bouncer to manage the number of connections that we have going to our database at the same time to manage concurrency. So I think sort of nothing completely crazy with that structure there. But our auth handler has some pretty particular requirements. And so I want you to think about as you're going to get on maybe you're going to get on the tube in a time when travel and being in crowds was a less fraught experience. And we need to make sure that we're able to respond to authorization requests within 200 milliseconds, because you're tapping your card or you're tapping your phone onto that turnstile, which is then going to our payment processor, which is then coming to us. We need to respond to that. Then they need to respond to TFL and then respond to the gate to let you through, which is where we have this required less than 200 millisecond response time. And so we're getting all this data from our payment processor as XML. And to make sure that we're able to have that very, very quick response time, we have a Django app in the structure that we saw on the previous slide set up, but without database access. We're making the decisions based on the data that we have in the XML that we get through, and then we're storing all of the logic of whether we want to make that go through or not within memory, so that we can have a really, really quick turnaround rather than having to wait on sort of database time, which would slow us down immeasurably. Well, measurably, but too much. And so actually thinking sort of like as we're going through this, there's probably better ways of doing this, that maybe storing data in sort of a much simpler server, and then again having it run through that logic on how it's going to respond to the request with a 200 or a 401, depending on whether we're it's an authorized or an unauthorized request. But the advantages of just using a Django app is it makes updating that sort of core logic a much more simple process for us, as well as meaning that the process of testing that logic is really straightforward. And again, we can share some of the code that we have, as we saw on the sort of slide at the beginning, between the base and the different parts, which can make sort of like the actual thinking about the core components of what we need in this transaction bouncer as a kind of a much more lightweight experience, and sort of like managing our context more easily. And so we can see like these problems have really described how we want to build the infrastructure for Parse. And Parse is quite exciting at the moment, because we've obviously come from a period where we had great success with many, many users, and then a time when people have chosen to travel less. And one of the great, I think, things for Pass that came out of the past 12 or so months is that people have actually kept hold of their subscriptions based on the flexibility that we're providing them in managing that, and we're at the process now of regrowing our active user base from sort of users who paused their subscriptions to using it again. And some of the fun challenges that we have coming up are how do we adapt our product for the changed travel behaviors that people might have now that more of us might be working from home on a regular basis, and the structure of our travel is maybe not, say, in the same 5-day-a-week pattern, or even in the same, same problems that maybe transport providers are having, where the physical pattern of our travel is changing as we maybe becoming more local, or maybe not. But we'll see. The future is quite exciting. So I think on this last page, we've got a list of some of the technologies that we're using on a regular basis at Citymapper, which is quite exciting. Always trying to work out what stays and what goes and what's the best way. So some of these technologies, for example, Starlet, are very new and used in but still pretty core systems, and some of them are pretty ubiquitous in the way we do things. For example, you saw us using Django servers for Citymapper Pass earlier. So as I said, as Sam said, so we're still growing loads of our cities and still have many problems to solve in the way that we want to deploy our Kubernetes infrastructure and make it as effective and efficient as possible. And the same goes for Pass as well, as we're sort of, as the product evolves based on people's changing behaviors. And if you're interested in tackling some of those problems with us, then citymapper.com/jobs is the place to be. Thanks.
Awesome. Thank you so much, guys. Great 2 presentations there. I don't think we have any questions from the audience, but one question, I guess, from me is we would love to just know a little bit more about how your engineering team structure is, because I know obviously some of the roles you're looking for are specifically for some of the features that you guys are creating. What does the engineering team look like? Is it squads really focused on those different features, or is it sort of everybody working across all of them?
So it's a little bit of both. We're moving towards kind of more product-focused teams, kind of full stack. But in recent history, it has been a little bit of everything on the back end, a little bit of everything on front end. But we're really trying to focus the teams coming up. So I think that's reflected in the jobs page as well. Yeah,
awesome. Yeah, no, it's really interesting. Lots of cool things. I'm a big fan of Citymapper, an avid user myself, so it's interesting to know a bit more. Guys, thank you so much for your presentation. If anybody has any more questions for Ben and Sam, feel free to just message them directly in the chat. You can also check out their jobs either directly on their career page, or if you go to the Expo section, you can find their jobs on TechTree too. Cool. Thank you so much, Ben and Sam.
Take care.
Thank you. So next up, we will be joined by Manuel, who is the CTO at Timeular. Welcome, Manuel. And I know, Manuel, you're going to be talking a little bit more about how you're tracking time with IoT. So if nobody hasn't come across the Timeular device already, I think you'll be very interested in what Manuel is about to present.
Hey there. Thank you for the introduction, Samuel.
Yeah.
Okay, so as Sam already mentioned, I'm from Timeular, and I will show you today how you can use a IoT device to track your time. So first of all, let's give me a short introduction what we do at Timeular and who I am. So our goal at Timeular is to help you to manage your time. And you might ask, why is time management important? So yeah, as you all know, there are only 24 hours in a day. And we think it's super important and for everyone to make the most out of their time. Something that is probably very remarkable about us as a startup is that we have a hardware IoT device, which you can see here in the middle. We call it a tracker, and I will explain more in detail later on. But also that we have been fully remote since 5 years already, so right from the get-go. Some facts about me. So I'm a co-founder at Timeular, and I'm the CTO and also responsible for product. My technical background is I'm coming from the iOS and generally from the mobile scene, and I've done a lot of Bluetooth Low Energy related projects in the past, which helped me a lot when starting out with Timeular. Before we dive into the presentation, I will give you a rough overview about our stack. So as I already mentioned, we have the hardware device, which we call the tracker. Then we have native Windows app, native macOS app, a native Linux app, iOS and Android app. I deliberately put native into air quotes, and I will explain later on why I did so. And on the backend side, we have a couple of microservices, which we host on Amazon AWS. Okay, let's start with the tracker. So first of all, I'll explain you how the tracker actually works. So the tracker has 8 sides and is connected via Bluetooth Low Energy to either your smartphone or your computer. You can assign projects, activities, clients, or whatever to each side of the tracker. And once you put the tracker on one side, it will start tracking the corresponding client or project. So we make time tracking really easy. So it's just a matter of putting the tracker on the right side. And internally, the tracker is based on a platform of Nordic, and the platform is called NRF52 more specifically. And additionally to the Nordic platform, we also use a gyroscope to detect the position, how the tracker is laying on your desk. You might ask why we choose to even go through the hassle to build the hardware. So we've tried a lot of time tracking software and time management software in the past by ourselves. And one thing that always was really annoying to us is that on purely software-based products, it's just like one other app that you have on your phone, one of 50 browser tabs that you have open. So ideally, you do time tracking in real time. But if it's just one of those many apps that you use at the same time, you simply forget about it. So it's super hard to build a good habit of time tracking if you're only using a software product. We thought that building a hardware which acts as a remote might be really helpful, and it turned out to be. But one thing that we discovered along the way, having the hardware constantly in front of you at your desk is also a good reminder on what you should focus on right now. And as a small bonus point that you can see in my slides here, when you build a hardware that is customizable, you get a lot of customer love on Instagram, and it's always a pleasure to get a mention and see how our customers customized our tracker. So those are just some examples that our customers shared with us. So so building a hardware device obviously has also huge implications on the software stack that we will be using. So as with most startups, we would have loved to build a web app because it allows us to really iterate fast. But having this hardware device, which communicates via Bluetooth Low Energy with your smartphone or your computer, required us to build native apps. Building fully native apps, meaning Objective-C or Swift on macOS, something on C++ or C# on Windows, and so on, is simply not sustainable for a small startup. So we went with a hybrid approach. Our goal was always to share as much code as possible, but where it makes sense, we dove down and implemented some parts in native. To be more concrete, we built our complete Bluetooth Low Energy implementation on the different operating systems natively. And on top of that, we have a shared code base, but I will explain you more about that later on. And generally in today's talk, I will give you an overview how the complete system works, meaning starting something with the hardware device and ultimately ending up in the cloud and syncing this event to all of your devices in real time. So the first step of the journey is the tracker. So when you stop working or in the morning before you begin working, the tracker will be in its base. That is the small black thing that we see here. And this means the tracker is currently sleeping and not doing anything. So to start your day and start time tracking, you simply remove the tracker from its base and it will wake up. Once it wakes up, it will start advertising. And here I need to explain you some details about Bluetooth Low Energy or how Bluetooth Low Energy in general works roughly. So there are 2 roles in a Bluetooth Low Energy relationship. There is the central and the accessory role. In our case, the tracker is the accessory, and the like desktop app or mobile app is the central. So once the tracker is put out of its base on the desk, it will start advertising, and the central devices, meaning desktop app or mobile app, are constantly looking if there is any tracker nearby that they could connect to. Once they see a tracker, they will connect to it. And advertising, sorry, I need to mention that. Advertising means simply shouting out to the world, hey, I'm a Bluetooth Low Energy device, you can connect with me, and I offer you the following services. And services are, in the Bluetooth Low Energy world, are characteristics. And characteristics usually like transport a certain value. So in our case, one example would be the charge of the battery, so how much charge is left for the battery, but also which side is currently facing upwards. So once you put the tracker out of the base, it wakes up, one central device will connect to it, it will subscribe to the site characteristic, and once the tracker is put on a certain site, it will send the site to the desktop app. So we have now two cases. So the first case could be that our desktop app takes the central role and is connected to the tracker or the mobile app. Let's go for the desktop app first. So once the desktop app connected to a tracker, it will read the site characteristic and see if the tracker is laying on any site. If it detects one of the 8 sites, it will do a simple mapping between site and activities. So in our software, you can assign like different activities to each side of it, and then it will start tracking this certain activity. So in this case, it's deep work. But also at the same time, it will make a call on our backend and start the tracking on the backend, so it can be synchronized to all your other devices. Because one thing that's also important to note here, that the tracking and all the data is in sync between all of your devices in real time, all the time. To give you more in-depth overview about the architecture, so we support macOS, Windows, and Linux as platforms, and our stack is native Bluetooth Low Energy implementation for all 3 platforms. Our native Bluetooth Low Energy implementation is open source, so you can have a look at it at GitHub. One like interesting fact here to mention is the Chromium team, like the browser team, is working on Bluetooth Low Energy support in the browser, and it's currently already available as a preview. And once they started working on it like a couple of years ago for their Windows implementation, they referenced our Bluetooth Low Energy implementation in a couple of conversations, and that was actually really flattering. On top of the native Bluetooth Low Energy implementation, we have shared code. So first of all, we share code, the complete like desktop app code between Windows, Mac, and Linux, but also we share the complete business logic between desktop and mobile. So this architecture simply allows us to move fast and also build all of our product with a relatively small team. And for this shared code base, like we use React as a like runtime to run our app on the desktop. And inside React, we have Electron. And inside Electron, we have a React application, which is written in TypeScript. So we started out with JavaScript, but like 2 years ago, we migrated all of our code base to TypeScript. So all the mobile app could also, or the mobile phone or app could also be in the central spot, meaning the mobile phone connects to your tracker. As I said earlier, we share the code base, which is written in TypeScript for the business logic also with mobile. And the UI is written in React Native. And again, the Bluetooth stack is written in like in native code in Objective-C for iOS and in Kotlin for Android. All in all, it works very similar to the desktop way, although the whole Bluetooth and background handling implementation was way more challenging on mobile, simply because background tasks are way more restricted on mobile. So you need to take more precautions here to make sure that your app is running, or get started once you receive updates from the Bluetooth device. So once the mobile app reads the site characteristic from the tracker, it will also start the tracking locally and then notify our backend. So the final part of this whole system is our backend. And on the backend, the start tracking event arrives at our time tracking service, which is one of our many services in our microservice architecture, and is also relayed to other services that might be interested in that event. and also put on a WebSocket connection. So all of our devices establish a WebSocket connection to our like cloud or backend, so we are able to sync them in real time. And like some general overview about our backend infrastructure. So as I said already, we use a microservice architecture. All of our microservices run inside Docker. The Docker containers are already orchestrated by Kubernetes, and we already heard a short and very good explanation about Kubernetes beforehand. We run at least 2 instances of every microservices at any given time. This whole system is hosted on Amazon AWS. And for languages, we use Kotlin, Rust, and Go. We've been using Kotlin since the start. And we've introduced some Go services and later on Rust services. And currently, we are investing more and more into Rust, and we will phase out all the Go services at some point. So going forward, we will continue using Kotlin and Go. And for the event handling and event queue, we use RabbitMQ as a queuing service. Some outlook. So as I said earlier, the Chromium team is working on Bluetooth Low Energy support in browsers. And this would actually allow us to port our application to the browser. It's already kind of a web application running in Electron. So having this like cross-platform and lots of shared code approach would allow us to port it relatively easily, though it will take some time until Bluetooth Low Energy support is broadly available to the major browsers and also like in a business context. Up until now, or up until then, we could actually use a hybrid model, meaning we could build small native applications for the different platforms, but move all the like visualizing the data, managing data, and everything like UI heavy to the web. And this would allow us to simply have like shorter and faster iteration cycles. Yeah, a short recap. I think the biggest takeaway here is that a seemingly very simple task, so start a tracking from a hardware device and sync it in real time to basically all of your devices, is actually quite complex and involves like a lot of steps and lots of moving parts. And I think like the biggest accomplishment of our engineering team is that we managed to build this like native or air quote native apps for lots of different platforms. And support lots of different platforms with a rather small team. So we currently are 3 engineers, front-end engineers, and 2 back-end engineers. So 5 people in total building this complete system. Yeah, and now it's your time to ask me any questions. And as I would like to mention here that we are currently looking for a front-end engineer. So if you're interested in working with us, and it's a fully remote position, yeah, feel free to reach out to me or to us in general.
Awesome. Thank you so much, Manuel. That's really interesting. I think you're probably one of our first actual hardware companies presenting at Show the Code. So it's really interesting to see that sort of different approach. I guess from from the perspective of your team, I know you're looking for a front end engineer. What's some of the key projects that they're going to be involved on? Right from the beginning? I know obviously you've shown us a lot of the sort of front end features. What's next, and what's going to be their biggest challenge?
Mm-hmm. So yeah, so up until now we are really focused on like building a time tracking product, but the time tracking product is simply the basis for the time management stuff that we are building. So because like time tracking builds the data that allows us then to recommend you how you can improve your time management. So in going on in the future, into the future, we will have more like interesting analytics and I would say proactive things in the app that we want to recommend to our users. And yeah, so if somebody starts us as a front-end engineer, they will like ship code from day one, although we are realistic about like expectations in the sense that this is a huge code base and it will take a lot of time or some time to get used to it and get up to speed with everything.
Yeah, awesome. Really interesting. Okay, cool. Unless anybody has any other questions in the chat function, I mean, like I said, you can always message Manuel directly here. Stick around, obviously, you can keep this tab open for a while and continue conversation. If not, definitely reach out to Manuel on LinkedIn as well as the other speakers. Thank you so much, Manuel, for a great presentation. And yeah, that was really, really awesome. Thank you.
Thank you very much. Thank you.
So guys, just to wrap up the event, a huge thank you to all of our speakers today. That was 3 really interesting presentations from 3 great startups, 3 great companies. Big thank you to our event partner, or two event partners, Connect Ventures, who helped put this together with their portfolio companies, and also to Silicon Roundabout, who you heard from at the beginning of the event. Our events are coming in thick and fast. We still have some events coming up in the future over the next few months, so keep an eye out for those. Anybody that would like to see the videos or presentations again from this event, we'll be sharing them via email to you all soon. But apart from that, thank you all for attending, and I hope you enjoyed the talks. Thank you.